Now, let us start our discussion on smart grid protocols and standards. So, if you see, the smart grid standards and protocols are divided into four subsections. This section is for transmission systems, and the protocols related to the transmission systems are IEEE C37.118, that is IEEE standard for synchrophasor measurements, which we have discussed when we discussed the phasor measurement unit. Then next is IEC 61970, which is Common Information Model for Energy Management System. So this we will discuss when we will talk about the smart grid interoperability. Then IEC 60870-6 is the Inter-Control Center Communication Protocol. So this protocol is utilized to communicate the data between two control centers. So this we will discuss when we will discuss the SCADA protocols. Then next is IEC 60870-5-104, which is for network access, and the 101 is utilized for serial data communication. So this also we will discuss when we will discuss the SCADA data communication. Now the second subsection is related to power distribution, where we use IEC 61850, which is utilized for substation automation. So this we will discuss in detail, and we will try to understand how 61850 can be utilized for standard data communication in substation automation. IEC 61968, which is Common Information Model for Distribution Management System. This we will discuss along with 61970 when we will talk about the smart grid interoperability challenges. Then IEC 62056, which is nothing but the DLMS COSHAM protocol, and this we have already discussed when we discussed the smart metering data communication. Then we have DNP 3.0, which is again similar to the 60870-5-104 and 60870-5-101. That means that we will utilize it for the SCADA related data communication. So in this course, we will mainly concentrate on transmission and distribution system protocols and standards. The other protocols which are related to energy markets are IEC 62325, which talks about deregulated energy market communication standards. Then AS 4777 is grid connection of energy systems via inverters. AS 4577 is framework for the control of electrical devices for demand response management. The fourth subsection is related to the smart grid security and the other time travel protocol related activities. So IEC 62351 talks about the smart grid security. IEC 61508 is required for functional safety of electrical, electronic and programmable electronic safety related system. IEEE 1588 is commonly known as precision time protocol, which is a standard for a precision clock synchronization protocol for network measurement and control systems. Some other protocols which are required from a smart grid point of view are the green button. So green button is initiative to provide utility customers with easy and secure access to their energy usage information in a consumer friendly and computer friendly format. Then multi-speak, this specification is a standard for the exchange of data among enterprise application softwares which are commonly applied in utilities. SunSpec is an open interoperability specifications and information model to achieve plug and play interoperability between distributed energy resources and smart grid applications. SEP 2.0 is the standard for applications that enable home energy management via wired as well as wireless devices that support Internet protocol. So these four standards are mainly related to the data interoperability standards. So this we will discuss along with the other interoperability standards in this course. Now first talk about the IEC 61850. So before going into the IEC 61850, first try to understand why IEC 61850 was developed. So initially the power substations were mostly managed by substation automation systems that were utilizing the simple, straightforward and highly specialized communication protocols, and these protocols were mostly the proprietary protocols, so they were less concerned about the semantics of the exchanged data. So because of that, there was no standard format of the data communication. So what the problem utilities were facing? The devices from different manufacturers were using different substation automation protocols, which were disabling them to talk to each other. And because of that, if utilities were buying the devices from one manufacturer, they were bound to buy the other devices also from the same manufacturer, because the devices of other manufacturers were not able to communicate with the devices of this manufacturer. So because of that, utilities were paying enormous money and time to configure the devices to work together in a substation. So hence, the device manufacturers recognize the need for a unified international standard to support seamless cooperation among the products from different vendors. And because of this need, the IEC 61850 standard was developed. So IEC 61850 international standard is drafted by substation automation domain experts from 22 countries. Now IEC 61850, so this protocol takes the advantage of comprehensive object oriented data model and the Ethernet technology. Part 1 to part 3 of 61850 talks about the general ideas about the standard. Part 4 defines the project and the management requirements in an IEC 61850 enabled substation. Part 5 specifies the required parameters for physical implementation. Part 6 defines an XML based language for IED configuration. Part 7 elaborates on the logical concepts. Part 8 talks about the mapping of the internal objects to the presentation layer and to the Ethernet link layer. Part 9 talks about the mapping from sampled measurement value, that is commonly known as SMV, to point-to-point Ethernet. Now let's first see the substation architecture in 61850 implementation. So in 61850 based substation architecture, we will have two local area networks. One is called process bus and second is called substation bus. Both are based on Ethernet and the speed will range from 10 Mbps to 1 Gbps in both of the cases. Now why we need two different local area networks? Because one is mainly required for the data acquisition, that is called process bus. So the process bus will be responsible to share the measurement data to the various devices connected in the substation. Here the merging unit plays an important role, where merging unit will club the voltage and current measurements and convert them into digital format, and only one data stream is required to be communicated to the process bus. If you do not have merging unit, the current and voltage measurements have to be individually communicated to the process bus. So merging unit will merge the voltage and current and other parameters if you are acquiring from the device into one single bit stream, so that the number of connections from merging unit to the process bus will be only one. Now here, why we want the process bus to share the data? Because if you are having wired connection, then the voltage and current measurements should be wired to relay as well as other devices such as meters for the required information. So if you are not having process bus, there will be multiple wirings required for each and every device to be connected to the particular data acquisition system. Now, if you are having the data which is traveling on process bus, all devices which are connected to that process bus can read that data. So this is what the advantage of having process bus and sharing the data on that process bus. So here, if you have the transformer data coming from current and potential transformers, and then it is being shared with the process bus, this information can be shared with the multiple relays and with multiple meters, so that they can take action on the acquired measurement. Now, what is the role of substation bus? Substation bus is the bus where all the software application servers are connected and the human machine interface is connected. So in the station bus, the refined information and the status and the control commands will be flowing. So meter will share the updated measurement and relay will share the signals and the commands at the substation bus. And this will be seen by the human machine interface. Now, if the end devices are not based on 61850, that means they are legacy IDs. ID means intelligent electronic devices. So you need 61850 wrapper so that the legacy data can be converted into 61850 and then it can travel over the substation bus. Now substation bus will be connected to the external world through the station gateway, and then this information will be shared with the control center or maybe with the remote operator or maybe other substations. Now in 61850, the virtualization is the key aspect on which the IEC 61850 is developed. So virtualization is nothing but the logical representation of devices which are there in the field using guidelines given in IEC 61850. So for example, if you have one bay in the substation where the transformers, circuit breakers, isolators and so on are connected, you need to first convert them into an equivalent software object for the necessary application. So what will happen in that case? The hardware bay will be first converted into a software bay, which will be nothing but a logical device. Now in that logical device, we will have multiple logical nodes such as transformers, circuit breakers, or maybe the data acquisition devices. So say for example, if you are mapping the circuit breaker will be a logical node within the logical device. So that logical node will have multiple data points, say position, mode, and so on. So this will be a virtual component of the physical bay which you are seeing in the substation. Why we need? Because we want to map it to the individual hardware component so that the required data can be mapped to that particular software object. Now these Data related information you can get in IEC 61850-7-4, while the logical node information you can get in 61850-7-4. The configuration files which are required to configure these logical devices and logical nodes can be referred in 61850-6. Now, various services required to map the logical node with corresponding service, you can get that information in IC 61850-7-2. Then specific communication service management, that is SCSM, which connects the required information to the MMS, that is manufacturer messaging specification, you can get in IC 61850-8-1. So this we will discuss when we will talk about the components of IEC 61850.